Hi, good morning, FIATech members and FIATech friends. I'm Nicole Testa Boston, the Deputy Director at FIATech, and I'm glad that you are all able to join us this morning for FIATech's weekly Technology Tuesday webinar series. Today we have an exciting hour set aside to talk about location tracking technologies, which Marcus Rourke from IntelligentInSites will be presenting. But before we get started with the presentation, I want to go ahead and introduce Marcus Rourke, who currently runs business development at IntelligentInSites, a leading provider of enterprise visibility solutions. Marcus is a high-tech executive and entrepreneur with a diverse set of industry experiences, including aerospace and defense, industrial automation, supply chain and manufacturing, and real-time location services. He's also served as a judge for MIT's entrepreneurship competition and is a regularly requested reviewer for the National Science Foundation Small Business Innovation Research Program. Marcus received a BS in electrical engineering and an MS in engineering management, both from Stanford University. He currently lives and resides in Austin, Texas. And with that, I want to thank you, Marcus, very much for joining us today. This is an area that's near and dear to a lot of our FIATech members and their companies, and we're looking forward to learning something in this next hour. So with that, let me turn it over to you.
All right, thank you very much, Nicole. Thank you for the warm introduction. I guess maybe warm is on my mind because I am in Austin and it's very hot here. I live in Austin, but my company, IntelligentInSites, is based in Fargo, North Dakota, and I haven't yet found a way to spend the summers in Fargo and the winters in Austin, but I'm going to work on that. I also have not yet succeeded in doing the 100-degree travel in a day, where I leave Texas and arrive in Fargo and get the 100-degree difference, but actually I can't really say I'm looking forward to that either. But let's go ahead and dive in. Like Nicole said, I will pause. There's two different points of the presentation where I'll pause and check in with Nicole to see what questions might have come up, and then again at the end of the presentation we'll try to address any questions that may have been asked. So I want to stay true to the title of this presentation. I talked about alphabet soup, and when you talk about RFID and location tracking, you're going to see a ton of acronyms. Now, I've put a lot of them on this slide here. I'm not actually going to cover all of them in this presentation, so if it turns out that you see 3 or 4 letters here that intrigue you or interest you, feel free to ask what that means if I haven't covered it by the time we get to the end. There's a couple here that are, I guess, I want to address right up at the front. Of course, RFID is the phrase and the term and the buzzword that we hear most often. That's radio frequency identification. The RFID comes in a couple of different flavors, but the companion phrase that I want to make sure we talk about today is RTLS, which is real-time location system. So you see those two acronyms right there in the middle, RTLS and RFID. There's a difference between the two, and in some cases, many of the use cases that you're going to want to use will require RTLS, but I'm still going to use RFID in most of these slides because that's the phrase that everyone is familiar with. Now, a couple of ground rules on this presentation. I'm not going to mention any specific vendors. There's a lot of technology vendors out there. In some of the images I have in the presentation, you'll see some vendor names, but I'm going to try to stay vendor agnostic. This is meant to be an information presentation as opposed to a discussion of where you might want to go buy or source different technologies from. My agenda is, I guess, to start out with, why should we care? Why is RFID important in the construction industry? And what kind of use cases make sense? And with that in mind, what do we want to track, and why might we want to track those things? After talking about that, I'll look into the technologies, the different technologies that are available. That's where you see many of these acronyms here. Then we'll talk about some specific real-world examples where RFID has been used in the construction industry and the benefits that have been seen from that. And then lastly, I'll talk about adoption. What are the barriers to adoption in the construction industry, and what kind of things can we do as an industry to encourage and to speed up adoption if that's what makes sense to happen. So let's go ahead and dive into this. I'll start with, who is IntelligentInSites? So my company is a software company, like I said, based in Fargo, North Dakota, and we're a we help organizations know where their people, their assets, their components, their inventory, where are all of those things, and what status are they in, what condition are they in, and what events and activities are happening to those items. In many cases, in fact, most cases, in real time. And we do that by providing a software platform that can take in data from a wide variety of sources and integrate with a wide variety of third-party applications. We also provide some of our own applications that sit on top of this platform, applications for asset management, for inventory management, and for workflow management. Our primary industry to date has been healthcare, but these enterprise visibility solutions are applicable to a wide range of industries: manufacturing, retail, food industry, and construction industry in particular. I guess I should also mention at this point, like the ground rule I said at the top, that I'm not going to mention specific vendors by name. We as a company, as a software company, are actually hardware agnostic. So we work with a wide variety of technologies and make the information that's coming out of those technologies usable by our customers. So, like this presentation, we are also hardware agnostic. So why RFID in the construction industry? I suspect that you will have heard probably all of these bullet points before. So part of it is, this is probably a repeat from what you're used to hearing. Materials management is a huge issue. And I have sources for all these, by the way. I haven't put them in the presentation, but this is based on research and real-world activities that have been seen. So if you're running inefficient materials management, that can lead to an increase in field labor hours of 50% or more. Some of these construction projects, particularly if you take a typical $200 to $300 million project, you're looking at 10,000 or more than 10,000 components that you're tracking, or that you need to keep track of, whether it's valves, fabricated components, pipe spools. Many of these end up on large lay-down yards outdoors, where it can be quite complicated to keep track of everything. In terms of the tools that are used, the tools and equipment that is used during the construction process, a number of sources have said that we're losing $1 billion or more per year lost or stolen tools, and that's increasing at a rate of 20% per year. And then making it quite personal here, when it comes to tools, a foreman can spend up to 1 hour a day looking for tools. So these are, hopefully these aren't a surprise to you, but all of these point to a need for a better way to manage materials and tools and people in the industry. Now, when applying RFID to construction, there's a number of different areas that can benefit. The first one I have on here is supply chain management and logistics. I'll try to give a brief example for each of these. Real quick example. When it comes to supply chain, if you're tracking materials from manufacturer and shipping through delivery to the job site or to the laydown yard, for instance, if you know when those things are happening and are able to communicate those processes, you can create a much more lean supply chain. So not only will you know when products have arrived, you'll know when the products you're looking for have arrived on site, and you can start to base your supply chain on just-in-time events. And instead of stacking up, I've seen some statistics that you want 60% of your pipes in place on the laydown yard when you're at the 20% point. Some companies are as high as 80%. There are ways to reduce this level of inventory if you have real-time information on your supply chain. In terms of tracking and tracing of components, parcels, and tools, this has some amazing impacts on laydown yard management if you know where things are. And we'll go into some case studies on that. Inventory management, do you have the right inventory at the right place at the right time? Product identification, this you guys will know this far better than I, but many of these things can be, particularly the parts that are out there and that are going in place and on a job site are very particular. The number of prefabricated components is increasing every year, and by putting RFID tags on these, you can get lots of information on that particular component, both its manufacturing history, its quality control history, and its installation instructions. In terms of maintenance of service systems, in the plant maintenance and post-construction process, there are ways using RFID to make sure that systems are being maintained properly and that you are in compliance with any kind of maintenance processes you might have. Equipment deconstruction, with an RFID tag, you can actually put the deconstruction information right there on the tag for that particular asset or component. And when it comes to environmental services, if there are particular activities that need to take place in a removal or deconstruction process, you can have those instructions right there in the field. Lastly, personal safety and security access. This is the only one that doesn't necessarily relate to a big pile of money, which is the image I put there. When I was thinking about this slide, I thought the most important things would be things that involved the bottom line. But when it comes to personnel safety and security access, some of these may be softer return on investment, but incredibly important, both to the quality of employment at your facility and at your job site, and for liability purposes. So let's take the first example of what you can do with RFID, and let's take a look at asset tracking. So if you're tracking components as they come into your laydown yard, you can figure out where those components are. And an example I'll give later, there's a 25-acre laydown yard, and you might be able to know where those components are in a 20-square yard area. Even the best laydown yards that are managed without RFID, you might be talking about a 5,000 square yard area for knowing where equipment is. When you're tracking equipment like this, you can verify that you have received all the components of the bill of materials that you need. And this can greatly impact scheduling, right? If you've got everything you need to have, that's fantastic. But if you don't, you know right away, and you can get the missing components on the site and in time to keep the schedule moving along. Tag identification we talked about, right? Knowing exactly what component you have, what piece of equipment or what prefabricated material, and you've got that ID there, and you can either have information right there on that tag, or it can be, I've seen the phrase license plate. You might have an identifier on that tag, and then you look up into a data store somewhere on the web what that particular component is. These might have installation instructions, and also deconstruction instructions, which I mentioned. All of these relate to having, really, I guess in my mind, the right amount of material at the right place at the right time. You see there a picture of some pipes in a laydown yard. I did not put a picture in here of a laydown yard covered in snow, but you can imagine that if you're looking for a certain piece of equipment or part or component in the winter in some of the northern regions, it can be very difficult when snow has fallen. This can also happen in desert conditions when sand might have covered up parts, or even, let's say in a jungle environment when vegetation might have covered up the parts. And RFID allows you to find those things even when they're covered up. Tool tracking is another big area for RFID. You saw the statistics, $1 billion a year in lost tools, and growing 20% a year. If you're tracking tools with RFID, you can start protecting against theft and loss and tool hoarding. Tool hoarding is where you might, because you on the job site, you know you need a certain tool at a certain point in time, you might hide it in a special location for you, but that's not as optimal as having it in a central location that everyone can access. And if you're tracking tools, you're less concerned about having someone else take it. And so there's that comfort level of keeping tools in a place where everyone can get to them. So again, you can do inventory management with this, with RFID and tracking of tools. You can by tracking each particular tool that has a maintenance schedule, you can keep track of that maintenance schedule for that particular item, know when it has been serviced, and if it is needing service, where it might be to get that service. And the last one I have on here is accreditation verification. Some of these tools and equipment require certain certifications by the operators, and with RFID, one of the things you can do is not only can the tool be tagged, but your personnel can be tagged, and you can actually do an association of the two, right? Is this particular person qualified to use this particular tool? And you can make sure that association is correct. And speaking of tagging individuals. Personnel tracking is a possibility here with RFID, and as you can see, this particular construction worker is fired up about being tracked. I mean, he is very excited about it. But with personnel tracking, you can do security access control. You can make sure that individuals aren't entering restricted areas that they shouldn't be getting into. That also affects safety, right? There's some areas that you don't want individuals getting into just from a safety reason. And in terms of safety, if you know where your people are and some sort of disaster happens, it's much easier to try to get those people out if you know their last known location. This also kind of applies to mustering, right? If you've got a situation where everyone needs to muster in a certain disaster preparedness area, you can make sure all those people are there, and you might know who you're missing in that case. And then lastly, alerting. Some of these RFID badges have buttons on them. So you can think of a duress situation, emergency situation, where one of your personnel can press that button, and not only do you know that there's a problem and that the person needs help, but you know their location. And we see this a lot in mining type environments. You can track time and attendance quite accurately when you're using RFID badges. And lastly, you can you can do task management and then compliance. One of the things I talked about was maintenance performance. If you're tracking personnel, you can find out if they've been near a certain machine or piece of equipment that needs maintenance, and in fact, how long were they there? Now, it's possible they were just standing next to the machine for the required 30-minute period that it might take to do the maintenance on that particular machine. So it's not a perfect solution, but you would know that that individual was in fact there. And if they said they were there and it shows up that they weren't, then you know that maintenance wasn't done. Now, sometimes we get questions about privacy when it comes to personnel tracking. Certainly happy to address what those conversations are like in the question and answer period. But when people start hearing the benefits of this, from a safety perspective and from a getting the job done perspective, and the fact that you're not going to track them in some private areas that you might not want to, like restrooms, I think people are generally quite agreeable to this. This is sort of a catch-all slide and other things you might want to track and monitor. There's lots of tracking of vehicles in rail yards. And certainly in manufacturing, there's lots of reusable container tracking, so containers, pallets, bins. Installed materials. One of the examples I'm going to give, a real-world example, is the prefabricated concrete sections are being embedded with RFID tags, which provides instructions on installation and also tracking throughout the supply chain. And lastly, you can have wireless sensors at various points to monitor humidity, temperature, vibration, the pressure, right? So there are cases now when wireless sensors are being installed in bridges and other building situations to monitor the stresses and strains on those buildings. So let me pause here to see if any questions have come up on either why RFID might be important in the construction industry or some of these use cases for using RFID in construction. And have any questions come up, Nicole?
Thanks, Marcus. Yeah, we do have two questions. Someone wants to know if you're aware of any interfaces that are available for tracking software programs that come with the RFID tags with the bill of materials reporting programs, which are often exported into Excel files.
Well, there are a few software vendors in offering services like this, and I don't know of any in particular, although I have read that this is certainly done. Writing interfaces, depending on the software platform that you're using, can be easy or difficult. I know we as a company have always worked to make it an easy thing to do to integrate, but because there's so much to integrate with out there, it's typically on a case-by-case basis. So I think to answer this particular question, it would be, what sort of software application are you wanting to integrate with, and then look at the potential software providers and ask them that question specifically.
Okay, and a similar question to that was, do you know of instances where the RFID tags are being tied to building information modeling software programs?
Yes, that is starting to happen, and I think we're going to, one of the examples I give at the end of this presentation, I believe that is taking place. So yes, that is certainly happening.
And one more question just came in. With passive tags becoming available for metal and price going up and active tags coming down in price, which do you think will become more prevalent in the days and years to come?
We will get into that in the next section. So if I don't answer that question coming up, let's bring it up again. But yeah, that's definitely a trend we're seeing, right? So, and let me cover that in these next few slides.
Do you have any idea how many unique tags you can have, assuming each tag should have a unique frequency?
The way these tags work is that depending on the technology used, it's not the frequency that changes, it's the information that is stored on each particular tag. So it's not a question of varying the frequency for a given technology. It's a question of how much data can that technology change or store. So that's not going to be an issue.
Okay, and just I guess to follow up from
one of the great things about passive RFID versus barcodes, or active RFID versus barcodes, and I'll get into this, is at least barcodes have traditionally been limited in how much of a unique identifier they can quote-unquote store, whereas RFID is fairly unlimited in that.
Yeah, and just to follow up, the gentleman who had been asking about the BIM wanted to clarify too and say that he was looking for the differences between the 2D barcode versus RFID, which I assume you'll get into here in a little more detail.
Yes, I will.
All right, great. Thanks, Marcus.
So that is a very good lead-in. This next middle section here of the discussion is about the technologies that are available. Now, barcoding is not actually, obviously not considered RFID, but I want to cover it in this presentation so we can do a comparison and contrast between what barcodes provide and then what the various RFID technologies provide. So let's start with barcodes. For each of these technologies, I'll list some of the options on the left and then go through the pros and cons, and there'll be some pictures in here as well. So barcoding obviously has been around for a long time. The UPC barcode, now it's called GTIN, which is Global Trade Item Number, is the one you see there sort of in the upper left. It's the traditional barcode you will recognize. Obviously in the last probably 10 years, there's been quite an evolution in barcodes, from the data matrix, which is the 2D barcode you see there on the right, and then there's a barcode called the PDF 417, which you're seeing, I think FedEx uses this particular barcode, and that's down there at the bottom. Now the pros of barcodes, they're inexpensive, right? This is going to be the cheapest form of tracking you can have, other than no tracking whatsoever, and barcodes are standards-based. So it's pretty interchangeable. If your materials end up, if your materials move through different companies within the supply chain, everything's working on a set of standards. The negatives of barcodes, though, and I think you'll be familiar with these, is that they require line of sight to be read by a barcode reader, and you often have to be fairly close. So not only line of sight, but you have to be fairly close. And this is not going to work in a laydown yard where your materials have been covered by snow or sand or vegetation, for instance, or when a part has been set down such that the barcode is facing down into the ground. Barcodes can be difficult to be picked up in bright sunlight. So if you've got your reader looking at a barcode, you might have everything perfect. You're there right in front of the barcode, it's facing upwards. But if the sunlight's too bright, you can get difficulty reading that. And lastly, barcodes do not provide real-time information. And you're going to see this differentiation as we move forward here with these technologies, a differentiation between real-time and not real-time. And so I'll just spend a quick second on that. Real-time means that at any given point in time, you have a very recent update on the location and status of your tag. So these are often done by tags that are beaconing or chirping at a set rate, maybe every 4 seconds, maybe every minute, maybe every 15 minutes. But this is considered real-time information because you know where that tag is at any given point in time. Things that are not real-time, like barcodes, you only know where that tag is at the moment it's been scanned. So if you imagine you're out there in the laydown yard and you scan a barcode, you might have a GPS, you might know where you are via GPS, and thus when you scan that pipe on the ground, you know where that pipe is. But as soon as you leave that laydown yard, you have lost that real-time information on where that pipe is. It can be moved in the laydown yard, it can be taken out of the facility. All these things might happen, but you only know that last known point in time when you actually scanned it. So you're going to see this real-time versus non-real-time throughout this, and different use cases are, demand different, I guess, versions on this continuum of real-time versus non-real-time. Different use cases will require one versus the other. Most of the benefits of RFID are taking advantage of real-time information. So let's get to passive RFID. Passive RFID is, I guess, the original RFID that you might have heard of. It has no battery, and it is an antenna which, when is hit with an external RF signal, it excites that antenna, creates a brief power source. It powers up a little chip right there. You can see it on this, I guess, the center image I have, top center image. Powers up the chip, and the chip responds to that power, and usually what it does is it sends out its data. And its data is usually a unique identifier for that particular tag. So when it broadcasts its data back out on that same antenna, and then the reader that originally energized that tag then listens to the response from the tag. So again, there's no battery on these. They're powered by an external RF source, which is called the reader. And it gets that power, gets the information off the chip, broadcasts it back out, and it's picked up by the reader. There's lots of different options of passive RFID. I've just listed, very generic examples here: low frequency, high frequency, ultra high frequency. In different countries, there are different standards for these. So UHF is actually the most common passive RFID that we see, but the frequency that's broadcasting on actually varies by international region. Before I go over these pictures here, I should say that passive RFID can be as thin as a sheet of paper, but as one of the questions mentioned, some of the more recent passive RFID tags are a little bit more substantial in order to increase their performance. So you see an example of that blue tag there that's in a plastic durable case, and also probably to raise it up from the surface of the material that it's attached to. So the pros of passive RFID, these are still inexpensive, more expensive than barcodes, but still inexpensive in the grand scheme of things. A passive RFID tag can range between 5 cents to, and some more expensive ones could get up to $5. But we're in volume. I've seen a recent press release that we're about to see some penny tags, so passive RFID tags down around 1 cent, and that's considered a fairly magic number. And once we get to that point, we're going to see a proliferation of passive RFID, which frankly everybody's been waiting for now for the past, say, 9 years. Passive RFID is standards-based. One of the acronyms you saw back there at the beginning was EPC. There's an international body called EPC Global, which manages the standards for passive RFID. Line of sight is not required, and you don't have to be, depending on the technology, you don't have to be terribly close. The read range of a passive RFID tag is a couple of inches up to 30 feet, right, for passive RFID. These tags also have, not only can they store data, that you might put on them one time, some of these tag categories can also allow data to be written to them. Now, I don't know that the industry will be taking advantage of that ability anytime soon. Some people say that we should be doing is just tracking unique part numbers and then storing the data in the cloud. right? Storing information about that asset using software. But that's some of the flexibility these tags offer. The negatives of passive RFID is you're going to get read errors with certain materials that these tags might be on. So again, there was a question referencing passive tags on metal, for instance. Well, it's true. When you put passive tags on metal or bodies of liquid, so if you've got a container that has liquid inside it, or sometimes even the human body, you can get read errors because those materials impact that tag's ability to pick up the RF signal. And so there have been tags that have come out recently that try to alleviate this problem. Passive RFID also has a short read range. In the spectrum of RFID, it has a short read range, right, from a couple inches to 30 feet. So that can be an issue sometimes. And like barcodes, there is no real-time information with passive RFID. You only know where that asset is or that tag is when you are reading it. In fact, when you are within 30 feet of it or smaller, and you excite that tag and get it to send out its information. At that point in time, you know where it is, but you don't know where it is any other time.
Excuse me, Marcus.
Yes, go ahead.
Before you go on, we're a somewhat cost-driven industry, and my switchboard lit up when you said tags for a penny. Penny tags. Folks want to know, are people really selling these for a penny, and are they full tags or just the inlays?
This was based on a press release from NEC that came out in, I think, April, where they expected penny tags in quantities of 10,000 or greater. Now, whether they are when and whether they are going to be delivering on that is an open question. But yes, it was considered big news. And no, I don't know if it's the full tag or just the inlay. My assumption is it's the full tag. In its most basic form, right? That thin paper type of tag.
Okay, great. Thanks, Marcus.
All right, so active RFID, now we're going to start getting into some of the differentiation between these acronyms. Again, RFID is radio frequency ID, and RFID started out with passive RFID. Well, it evolved a bit to what was, I guess, so I've listed two options here, battery-assisted passive RFID and semi-passive RFID. I want to make a distinction between active RFID and real-time location systems, because active RFID still needs to be scanned by an external source. It just so happens that these are battery-assisted, so these tags have batteries inside them, and when it receives that external source from a reader, it uses the power of the battery to amplify its response signal. So it's going to have much longer read ranges and can work on, and because the signal it's broadcasting is more powerful, it can work on a wider variety of materials than passive RFID. But you'll see, again, this is getting into a bit my opinion on what these different things should be called. So you'll see the phrase active RFID applied to many different technologies, but here I'm using it to apply to non-real-time tags that are battery-powered, but they only broadcast their information when requested by an external source. Oh, before I move on, an example of this, an easy to recall example of this are the toll tags you might have in your car. So those Easy Pass or toll tag or fast lane in the Massachusetts area, when you're driving underneath those tolls, the reader excites the tag and the battery in there amplifies the response back to those toll gates. So that's a typical battery-assisted passive RFID application. So the pros here, the cost is starting to climb on these, but you get a longer read range. The read range for active RFID can be 60 feet all the way up to 300 feet. So that's 100 meters of read range there. The price range for these seems to be around $10 to $20 maybe for the tag. Although when you talk about an all-in solution, because now, with software and everything, I've heard as high as $25, even $30 a tag for some of these. They're effective on difficult materials, but still, as a negative, there's no real-time information. And by that I mean, because how I've defined active RFID here, although these are battery-powered tags, they're only coughing up their information, right? They're only broadcasting their information when they are excited by an external source. So let's get into RTLS, Real-Time Location System. I've broken this into two categories because the technologies can be quite different. I've broken it into outdoor locationing and indoors. The biggest difference in the way I've structured these different categories between active RFID and RTLS, Real-Time Location Systems, is that these RTLS tags are beaconing. They are at a periodic interval sending out their information, and sending out a signal that can be used to locate them in real time. So as opposed to requiring someone to get near them with a reader, or as opposed to them going through a checkpoint at a gate or an entrance to a laydown yard where you might have readers surrounding the gate, these things are always sort of saying, here I am, here I am. It could be some of the indoor technologies, it's every 3 seconds. Some of the outdoor technologies, in a laydown yard, for instance, you might be okay with every 30 minutes. But like clockwork, these things are broadcasting information about themselves, and we're using that to find their location in real time. Options here, there's some battery-powered RFID solutions. I guess that's sort of what that vendor has called them. But these can be standards-based or proprietary RF, where it's sending out using radio frequencies, a pulse or beacon every so often. And you can also do Wi-Fi tracking outdoors. If you've got the access point infrastructure up, I would certainly imagine this would be used in smaller cases as opposed to larger areas, but Wi-Fi can be used for outdoor tracking. And that's leveraging an existing Wi-Fi network or perhaps an enhanced Wi-Fi network and using that to triangulate the source of the tag. So there you see an example of a beaconing battery-powered RFID tag and then a Wi-Fi tag there in that person's hand. So the pros, you are finally now getting real-time location information, and you're also getting some pretty good accuracy on where these things are. And perhaps those go hand in hand. But with these two technologies, you can see, in the 20 to, let's see, this is outdoors, so the numbers I've seen, 20 to 40 yards, you can get even smaller than that, depending on what kind of infrastructure you want to put in place. When I use the phrase infrastructure, and now that we're talking about real-time location systems, these tags are beaconing, so you have to have antennas or readers or monitors that are receiving this information, and then using the power of the received signal or the time difference of arrival of the signal or the angle of arrival. You can use different techniques to triangulate where that item is located. And sometimes, the more sensors you have listening to these little beacons, the more accuracy you can get. The cons, we're starting to go up in cost here when you're talking about these. So most RTLS tags are in the $30 to $50 range. And that's true both for indoors and outdoors. And of course varies by quantity and varies by manufacturer and technology. But these days that's a pretty safe price range, 30 to 50. There are infrastructure requirements I described. And when you start talking about RTLS, which is beaconing at a set rate, you do need to start asking questions about battery life. Now, fortunately, this has markedly improved even over the last 2 to 3 years. It used to be the case that some of these tags would last 1 or 2 years. These days, both for outdoor and indoor tracking, we're seeing the life of the battery itself being the limit. So it's no longer that the tag beaconing is draining the battery. You're getting the life of the battery, which can be 8 years, sometimes even up to 10. Although most battery manufacturers will tell their hardware customers not to guarantee anything more than 8. But it's certainly a question you should ask if you're exploring RTLS, which is what is the battery life of those tags? And then what happens when my battery starts getting low? Because you certainly want these technologies to be able to communicate to you that you're in a low battery situation so that the asset doesn't fall off the grid before you have a chance to go out there and put a new tag on it. When it comes to indoor tracking, and you might want to do this inside your plant or facility or even inside your office, there are a lot of technologies. So the two we just discussed are also available for indoors, the beaconing, battery-powered RFID, and Wi-Fi. And then there are other technologies that can work in Zigbee. I've got some examples of each of those. Infrared tracking works, both infrared and ultrasound work great for knowing exactly what room you're in. So if you have any requirements for room level tracking, you need to know exactly what room something is in. These technologies work great, and that's because light or sound does not do a good job of escaping the four walls of an enclosed room. So you get really good accuracy at a room level. Ultra wideband is we actually see a lot in manufacturing because of the precision and the strength of the UWB signal in noisy environments. As you can imagine, if you've got a manufacturing operation with lots of metal and steel, something like Wi-Fi might have some difficulty, whereas ultra-wideband still does a good job dealing with that noisy RF environment. And ultra-wideband can get down to, depending on how many sensors you put up to listen to those ultra-wideband tags, can get as small as 6 inches. Most customers don't need that sort of accuracy, so that you're talking, 1 to 3 feet. But the accuracy of ultra-wideband enables you to, for instance, know when a part or a material or work in process inventory has moved from one work cell to the next. And as the sizes of work cells are decreasing, we're seeing a lot more of that requirement. And then lastly, Zigbee. Zigbee is a low power location track. Well, Zigbee is a standard, an RF standard for low power mesh networks, and we're seeing tracking using Zigbee indoors. Pretty nice, pretty easy to install a Zigbee infrastructure because it's a mesh networking technology. You can plug your sensors into outlets in the wall, right? And just by putting a few of those every a couple hundred square feet, you can quickly build up a mesh network for highly accurate location tracking indoors. So the pros, it's still real time, right? These tags are beaconing some of these indoor technologies every 3 seconds. So very precise and recent information, and the location granularity can be great with these indoor technologies too. The cons, these are more expensive, right? Roughly the same tag price, but the infrastructure and both the price of the tags and the infrastructure has come down markedly recently. As with everything, I didn't put expensive, I put more expensive, and the reason why is the bottom line is not so much the cost, it's the return on investment. And can you build up a scenario in a case where the benefits of these technologies have a quick time to pay back, regardless, or I guess keeping in mind the cost, is the time of payback, does it make sense? And is the ongoing return on investment meaningful? And I know there was a Tech Tuesday presentation just a few weeks ago on return on investment, specifically focused on ROI for RFID. So I would encourage you guys, if you didn't see that one, to go back in the archives and take a look at that, because it walks through some ways to build up ROI internally in your organization to see if these are good solutions for you. Again, pay attention to battery life for these tags. Again, that's less of an issue these days, but it's certainly there. All right, global positioning system. This is an outdoor technology, and it is, an explosion of GPS lately, of course, so this is kind of obvious, but there's various GPS technologies you can use. I have an example. So you see here a handheld reader that knows where it is, so it has a GPS chip inside it, and when you scan a passive RFID or an active RFID, you know that point of where it's been scanned. There's an interesting, I guess, active RFID location solution out there that when you are, let's say, out in the laydown yard walking around with your handheld scanner, in the background it is picking up, it's activating all the tags nearby, and even if you're not looking for, you might be looking for one particular tag, but even while you're doing that, in the background it's sort of noting the location of all the other tags, and sort of doing a strength of signal analysis to figure out where those tags might be with the GPS chip inside here. There are tags that have GPS embedded in them, and the tag on the upper right, it records where it is during a journey using GPS, and then gives you that information when you scan it with a reader. So it spits out that historical tracking information. So it's not really real-time GPS, but it does have that information. Then you can imagine mounted tags. There's a tag in the lower right-hand corner with an antenna, and knows where it is via GPS, and then can communicate that data back in real time. So the pros are it can be real-time location information, And another pro is you don't have an infrastructure requirement. GPS is using the GPS satellite network, so the government is providing the infrastructure for GPS tracking. You will need to get this information communicated back into your network, and that can typically happen via the cell phone network using GPRS, or it can happen over your Wi-Fi network. The cons: GPS is still fairly expensive, and it requires power, so battery life can be an issue. I guess GPS is one case where battery life is not as long as the shelf life of the battery. So certainly, if you're considering a GPS solution, which might make sense, particularly if you're on an asset that has power, like a vehicle, GPS could work. Tag size GPS quote-unquote tags are going to be bigger than some of these other tags. The last part of the solution, so we've been talking about all the different hardware technologies because I wanted to hit some of those acronyms in the alphabet soup, but what ties it all together is the software that is integrating with this technology and then integrating with your back office systems. So some of the things to look for when you're looking at the whole solution and the software portion of it is, does the software, can it be deployed in either on-site, you might have your own data center, or can it be provided as a service, right? Software as a service. Can you have access to the software through a web or through a PDA, and the software vendor maintains all that data and provides all those services, the maintenance and the upgrade. You're going to want to look for a platform approach. So does your software provide a near-term answer to your solution, but also that long-term flexibility as you might add different technologies? Can the software work with different technologies, and can it integrate with a variety of communication systems? So when we talked about personnel emergency situations, if you've got someone who wants to initiate an alert or an emergency through pressing the button on their tag, you want to make sure your software can get that notification out through whatever communication system you happen to be using, whether it's cell phones or pagers or email, or even integrating with building systems, right? You might want to fire off alarms or control lights within your building system. So a platform approach can give you that. You're gonna want integration with your back office applications. We talked about that a little bit earlier. And lastly, you're going to want easy-to-use end-user applications. I mean, certainly in this industry, you don't want your people worrying about learning complex software. These things should be easy to use, and it should answer the questions that they have and answer them quickly. All right, I'll pause here for any questions. And Nicole, has anything come up?
Oh, yes, thank you. Do you know, are the battery-operated tags available in explosion-proof formats? And if so, what is the price consequences if they are?
I do not know the answer to that.
Okay.
But sign me up for that particular job. That sounds interesting.
Well, it's coming from a chemical company who they have, I guess, safety requirements as far as
Right.
Anti-explosion.
Well, the search engines are your friend here, so I would you can either follow up with me and I can take a look at that for you briefly, or you can look online for that.
Great. Can you tell us what the difference in terms of accuracy is between the GPS and the RTLS?
Unfortunately, the answer to that is it depends. I mean, all of these technologies, first of all, can vary in their accuracy based on the conditions and how dense you have your infrastructure. So have you placed your readers every 1,000 feet, or have you placed them every 100 feet? GPS itself can depend based on the particular GPS technology. There's a form of GPS called assisted GPS, which can take advantage of more satellites, or it can take advantage of local Wi-Fi signals. So unfortunately, the answer to that is it depends.
All right. Is there a standard for active tags like the passive Gen 2 standard? And can I mix and match active readers and active tags like I can with Gen 2 tags?
If we're talking about battery-assisted passive tags, yes, there are some EPC global standards for production, and they have different classes, different categories of those battery-assisted passive tags, and their standards for that. When you start getting into RTLS and all these different real-time tracking systems, no, there's a lack of standards because the underlying technologies themselves are so different. So, Nicole, because we have a few minutes left here, I want to get real quickly into some of these case studies. Is that all right?
Great, yes.
Okay. So 2 real-world examples. I'm going to go fairly quickly on these. They are interesting, though. And perhaps the most interesting, you may have already heard of, in fact, but it was a 3-month study run by Fiatech and the Construction Industry Institute and several other participating institutions here in Rockdale, Texas, or actually nearby me in Rockdale, Texas. They were building 2 boilers, and this was a great opportunity to run an experiment. With one of the 2 boilers, they tracked 400 of the steel support components using RFID. They did not do any RFID tracking for the other boiler. So you had a head-to-head competition here, tracking with one boiler using RFID and tracking using traditional techniques like paper-based tracking for the other boiler. And the results were pretty impressive. There was an 80% reduction in search time in the laydown yard. That was 37 minutes on average via the traditional method for the one boiler, down to 4.6 minutes for the boiler that was using the RFID. And when I ran the math on this, and it's possible I'm wrong on this, but that came out to about 215 hours saved over those 400 steel components. And over a 3-month period, that's about 70 hours per month of savings. So now the question is this just labor savings, or is this savings that can affect your schedule? It's probably a combination of both, but I think there's a huge opportunity here to reduce schedule delays based on the inability to find things. The other example is happening right now. Skanska USA is building the new Meadowlands Stadium in New Jersey. It's about $1 billion facility scheduled to open in time for the 2010 football season. And they are tagging more than 3,000 precast concrete components. So the tagging is happening at the manufacturing site, and the concrete prefab pieces are showing up at the job site. And they're scanning these are passive tags. They're scanning them at 4 different points during the process. They're scanning them at manufacturing just prior to shipping. They're scanning them at arrival at the job site and just prior to installation. So not only do they have visibility into their supply chain at those 4 points, but just prior to putting these components, or just prior to installing these components, they're verifying, that they've got the right piece in the right place, and they're recording that they have correctly installed that piece. And they're projecting savings of $1 million during this project from this effort. Other examples, of course, we talked about tool tracking. There's a fleet management example where the fleet vehicles are rigged with a smart ignition system that only turns on if a person wearing the appropriate badge is in the vehicle. So it's making sure that vehicles are only driven by certified personnel or authorized personnel. Nuclear power plant construction, there's an example where cables have been tagged, and they're making sure that the right cables are attached to the right things. And then what I thought was pretty interesting, an example where bolts have been tagged, and the digital torque wrenches they're using on those bolts have been tagged, and they're able to record for each for each bolt how much force was applied when it was fastened. They're able to know, of course, the time when it was fastened, and they're able to track if every single bolt was fastened appropriate per spec. I thought that was pretty interesting. So what's taking so long in getting this adopted? Well, I think there's a cautious approach to technologies. I think there's a lack of awareness about what RFID can do, and then certainly there's some confusion about RFID given all these different flavors. There's a high cost, or as I put in here, perceived high cost, because in my mind it's not, the cost does matter, but it matters in so much as you need to build a return on investment and a time to pay back that makes sense given that cost. lack of publicized success stories and ROI. So I think if there were more of these stories and more of these return on example investments, I think there'd be some faster adoption of these technologies. So how do we as an industry encourage faster adoption? Well, I think industry education is a big part of it. And actually for all of these organizations like FIATech are serving a huge purpose. I think we need to see more pilot projects. So I think there should be perhaps more collaboration between vendors of these technologies and construction firms and owner-operators to try some of these things out and generate more success stories and more return on investment analysis. One of the questions was on standards. I think it might help if there were some standards out there. So I do get this question a few times when I'm presenting all the different flavors of RTLS. I don't have an answer. I don't have an answer for when standards are going to happen. I think they could help in the adoption so that there's some increases the comfort factor of adopting these technologies. I know with our platform approach, we're providing a standard in the sense that we're interconnecting all these different technologies, and certainly you can have your software do that for you, and just make sure everything works together. But I do think some hardware standards might help. And then lastly, you guys have the ability to push your suppliers, or maybe it's pull your suppliers to start tagging some of these components at the start of the supply chain so that when they show up at your back door and in your yards and in your job sites, they're already tagged per your specification or per industry standards, and that you're tracking these things throughout the supply chain. So that is it. Are there any last questions that have come, Nicole?
Here's a couple. Do you know specifically what technologies were used for the boiler plant and football stadium examples you showed a few slides back?
Yeah, if you could have that person send me an email, and I will make sure they get the right information. In general, the boiler plant example, it was a battery assisted passive RFID solution where all those steel pipes were tagged, and then when crews went out to move those items, they had a handheld scanner that had GPS embedded in it, and that scanner was, exciting those tags, reading the location of those tags. So it was, the location of those items was known only as frequently as people were out in the laydown yard looking for things or moving things around. The Meadowlands, I don't actually know. That one, it's some form of passive RFID embedded in that concrete. I don't exactly recall the vendor. But actually, both of these are also easily searchable online. You can search Skanska USA Meadowlands RFID, and you'll get enough articles on that one.
All right. Well, we do have some more, but I think we've run out of time. So I would ask anyone who had sent a question in that we didn't get to take down Marcus's email and phone number here, and please follow up with him. We will also, as I said, tomorrow be posting a sanitized copy of the presentation on the FIATech website and audio recording in the web archives. But I also wanted to remind everyone that FIATech has been working on an RFID cookbook, which will be released shortly sometime this summer. And if folks want copies of the report that we did jointly with CII, please send me an email, and we can get that to you as well. But Marcus, I want to thank you again. This was very informative. Great presentation, and we really appreciate you taking the hour to share this with us.
No, thank you very much. I appreciate it. I hope this was somewhat helpful, and feel free to reach out to me if you have any follow-up questions.
Great. With that, thanks everyone, and we will have another webinar next Tuesday. Please check our website for the schedule and details, and have a great week. Thank you.